Hello, my fellow mathematician. Welcome to the study of O.D.E, whereby you are going to solve this O.D.E by the method of variation of perimeters. So, to solve this by method of variation of perimeter, we are going to write the reduced form as follows. So, reduced form will be equal to y double prime plus y, which is equal to 0. Then we let our y to be equal to exponential mx. Our y single prime is equal to m exponential mx, and our y double prime, and differentiating this twice will give you m squared exponential mx. Then we substitute to get m squared exponential mx plus exponential x. This is equal to 0. Now exponential mx cannot be equal to 0, which means that our m squared plus 1 is equal to 0. So m squared is equal to -1, which implies that m is equal to plus or minus I. So our complementary part solution will be y is equal to c sine of x plus c2 cos of x. So that is our complementary part. By variation of perimeter method, we let our c1 to be equal to a function of u1x, which is equal to u1, and our c2 to be equal to u2x, which is equal to u2. So by variation of perimeter, that is what we are going to have. So that now we shall have u1 prime y1 plus u2 prime y2 is equal to 0, and u1 prime y1 prime plus u2 prime u2 prime y2 prime is equal to f of x. In our case, f of x is equal to tan of x, which is equal to tan of x. So y complementary will be given by this one y1 plus c2 y2. Now when we substitute this value here, we are going to have u1 prime sine of x plus u2 prime cos of x. This part here is equal to 0, sorry. That part here is equal to 0. This one here is equal to 0. Now, we can write this in terms of vector, matrix sine cos x negative sine x bracket u1 prime u2 prime. This is equal to 0 tan of x. So the first thing we are going to do is to get what is called the Wronskian. Wronskian is written as y1 y2, which is equal to determinant of sine of x cos of x negative sine of x determinant. Now when you get this determinant, you are going to get your result as this is negative sine squared x. So you multiply the mean diagonal minus the other diagonal minus cos of x squared. Here it will give you -1. Then from there now we I'm going to obtain u1 prime is equal to 1 over function, that is 1 over -1, determinant of 0 tan of x cos of x negative sine of x, which is equal to, this will give you negative into bracket 0 minus tan x multiplied by cos x. This can be written as tan of x cos of x, which is equal to sine x over cos x multiplied by cos x. Writing tan in form of cos and so from here, cos and the cos will cancel, and we are going to be left with u1 prime is equal to sine of x. So you integrate both the signs to obtain u1 is equal to negative cos of x. u2 prime is equal to 1 over function, that is modulus of or determinant sine of x cos of x O and that. So this will give you negative 1 into bracket. When you multiply this will give you sine x multiplied by tan x, which is equal to minus sine of x multiplied by sine of x over cos of x, which is equal to sine squared x over cos x. So our u2 prime is equal to sine squared x over cos x. From trigonometric identity, you can write sine squared x as there is negative out there, negative bracket 1 minus cos of x squared divided by cos of x, which is equal to 1 over cos of x minus 1 minus cos of x. So our u2 is equal to 1 over cos of x minus cos of x. So to get u integrate, so u2 is equal to integral of dx over cos of x minus integral of, even this one is negative, this one will become plus because of this negative here and here negative. So plus cos of x dx. Now in this case, when you integrate cos of x, this one will give you, so integral of cos of x dx, that one will give you sine of x. Now from here now, we are going to write this as negative sec of x integral dx. That is what we are going to write it. Then, which can be written as negative integral sec of x into bracket tan of x plus sec of x, you divide by sec of x plus tan of x dx. Then from there, we let our u to be equal to the denominator, which is sec of x plus tan of x, so that we get du. We integrate this, which is equal to sec of x tan of x plus, when we differentiate tan of x, we will get sec of x squared, everything here dx. Now when you look at our du is the same as whatever is in the bracket, because this is sec of x tan of x plus that. So integral of sec of x, negative is outside, dx is the same as negative into bracket integral du over u. which is equal to negative natural logarithm of u, meaning that integral of sec of x negative outside dx is the same as negative natural logarithm of sec of x plus tan of x. So our u now, our u2 becomes from what we found there becomes sin of x minus natural logarithm of sec of x plus tan of x. That way. Then from there now, we write our yp. Our yp particular part will be given by u1 y1 plus u2 y2. Note that our y1 is equal to sin of x plus our y2 is equal to cos of x. So our u1, we found our u1 as negative cos of x. So we are going to have our yp is equal to negative cos of x sin of x, then plus cos of x into bracket, this part here, sin of x minus natural logarithm of sec of x plus tan of x. That way, you can see cos of x multiplied by sin of x, and this one here will cancel, so that our yp will be now, we are going to be left with the cos of x negative, because of this negative here, natural logarithm of sec of x plus tan of x. Now finally, our solution will be given by y is equal to yc plus yp. Our y, which is equal to c1 sin of x plus c2 cos of x, then minus cos of x natural logarithm of sec of x plus tan of x. So that is our solution of our given ODE. Our ODE was y double prime plus y is equal to tan of x. So that is our solution using the method of variation of perimeter. So thanks so much for taking your time to study with me. For further studies of such cases, kindly check in my channel so that we may continue learning together. Bye bye. See you in the next video. If you have not yet subscribed to this channel, kindly consider to do so that we may continue learning together. Thanks.